Hello everybody, how are you? Hope you are safe and healthy. Welcome again to our biology session. Today inshallah we'll start a new unit number 4. The first lesson will be the fossil record. So guys, what is the advantage of the fossil record? Actually, fossils are a record of what of life that existed in the past. So by studying these fossils we can understand what events happened over millions of years ago. So guys, the key concept here: specific environmental conditions are necessary in order for fossils to form. So let us see how can fossil form, guys. Actually, fossils can form in several ways, and today we are gonna discuss about five methods by which fossils can form. So the first way is permineralization. Permineralization, guys, occurs when minerals carried by water are deposited around a hard structure, and guys, sometimes they may also replace the hard structure itself. So this is what we mean by permineralization. Okay, so again, the minerals will deposit around the hard structure, or sometimes these minerals will replace the hard structure itself. Okay, the second method by which fossil can form is, guys, the natural cast. Natural cast is a kind of fossil that will form when flowing water removes all of the original tissue, leaving an impression. So here the impression will be left where? In the sediment. So guys, again, natural cast form when flowing water removes all of the original bone or tissue, leaving just an impression and sediment. So minerals fill in the mold, recreating the original shape of the organism. So this is the method by which a natural cast, which is a kind of fossil, will form. So what about, guys, the third method, the third way by which the fossil can form? Okay guys, here we have something called trace fossils. And guys, trace fossils record the activity of an organism, and they include what? They include footprints, as we can see here, or imprints of leaves, nests, or burrows. Okay, so trace fossils record what? Record the activity of an organism. So what about the fourth way by which fossil can form? Guys, this is so interesting. And here what do we have? We have an amber preserved fossil. So amber preserved fossils are organisms that become trapped in tree resin that hardens into amber after the tree gets buried underground. So guys, sometimes some women use this amber preserved fossil as a piece of jewelry. So it's really interesting. I don't know about you girls, but I really would like to have one of it, but with a butterfly inside. So anyway, guys, the last way by which fossil will form is what? Through the preserved remains. So preserved remains form when? They will form when an entire organism, as you can see here, the entire organism becomes encased in material such as ice or volcanic ash, or immersed in rocks. So this is, guys, as you can see here, an entire body skeleton that has been encased in what? Encased inside ice. So guys, here we should know that in order for the fossils to form, the body should not decompose. That's why we need most of the bone to be preserved in a certain way, whether it will be preserved inside or inside the volcanic ash, or whether it will be preserved in the resin of the trees, or whether it will be preserved in ice, such as this body in this photo. Okay, so the key here for any fossils to form, that they should not decompose. Okay, so guys, here let us discuss a little about the process of mineralization. As you can see here, guys, specific conditions are needed for fossilization, and because of that, only a tiny percentage of living things become fossils. Okay, so for example, for mineralization to occur, it requires what? It requires rapid burial in an area with water and continuous sedimentation, as you can see here. So guys, what will happen here? An organism dies in a certain location, such as a riverbed, where sediments can rapidly cover its body. Then guys, what will happen next? Over time, pressure from additional sediment compresses the body, and minerals slowly will replace all hard structures such as bone. So guys, after the formation of fossil, how can we study this fossil and use them to age the earth, or to study and understand what events happened millions of years ago? So guys, actually we need to want to estimate the age of fossils. There's two main methods by which we can do that, guys. The first one we call relative dating, and guys, relative dating estimates the time during which an organism lived by comparing the placement of fossils of that organism with the placement of fossils in other layers of rock. So guys, relative dating allows scientists to infer the order in which groups of species existed, although it doesn't provide the actual ages of fossils. So relative dating will not give us the actual age of these fossils, but it will give us the estimated age of these fossils. So another way by which we can age the fossils is called, guys, obsolete dating. And obsolete dating, or what we call radiometric dating, actually here we are giving the actual age of these fossils, not the correct, but the actual. And there is a difference between actual and correct, the correct age. So guys, radiometric dating is what? Is a technique that uses the natural decay rate of unstable isotopes found in materials in order to calculate the age of that material. So again, guys, radiometric dating is a technique that uses the natural decay rate of unstable isotopes found in materials in order to calculate the age of that material. And isotopes, what are isotopes, guys? As we know, isotopes are atoms of an element that have the same number of protons, but they have different number of neutrons. So most elements actually have several isotopes. For example, here we have two isotopes for carbon 12 and carbon 14. Carbon 12 we have 6 protons and 6 neutrons, but in carbon 14 we have 6 protons, the same number of protons, but we have 8 neutrons. So guys, some isotopes have unstable nuclei, and as a result their nuclei undergo radioactive decay. Here, guys, they will break down over time in order to reach a more stable status. So this releases radiation in the form of particles and energy. So as an isotope decays, it can transform into a different element. So the decay rate of many radioactive isotopes has been measured and is expressed as the isotopes have life, as shown here in this figure. So guys, what do we mean by a half-life? A half-life is the amount of time it takes for half of the isotopes assembled to decay into a different element or as a product isotope. So guys, as we can see here, for carbon-14, for example, and actually for both of the carbon-12 and 14, they all will decay into a new element, which is the nitrogen element. So guys, we need to add here an important note that carbon-14 dating can be used to date objects only up to about 45,000 years old, but if the objects are older than that, actually the carbon-14 dating will not be helpful. That's why for older objects, the older objects will be dated by using an isotope that has a longer half-life, such as uranium. So we usually use uranium to estimate the Earth's age. As we know, Earth's age is about 4.5 billion years. That's why we can't use carbon-14 dating for the Earth or to estimate the Earth's age. So guys, that's all for today. Thank you, and see you inshallah tomorrow.